Hello class, welcome to exercise 7b, sketching parabolas and using transformations. In this lesson, your examples and pre-learning will be example 3, sketching with transformations. And your pre-learning for this example will be questions 1 and 2 in the new book and questions 4 and 5 in the old book. And then we'll do example 4, which is using the turning point form. And your pre-learning for this example will be question 4 in the new book and question 6 in the old book. And then we'll do example 5, which is finding a rule from a simple graph. And your pre-learning for this example will be question 6 in the new book and question 8 in the old book. So in our last lesson, we've introduced the concepts of turning point, axis of symmetry, and the x and y intercepts. And we learnt that these properties are how we identify different parabolas. And these different parabolas are just y equals x squared, having any amount of transformations. Dilation, reflecting about the x-axis, and vertical or horizontal translation. Now, if you're not 100% clear in any of those, make sure that you spend a little bit of time working back over the previous lesson. All right, we'll see you in the introduction then. So the focus of this lesson is looking at quadratics in the turning point form. And that is when we express a quadratic as y equals a times x minus h squared plus k. And when our quadratic is in a turning point form, the turning point is hk, i.e. a point that has x value h and y value k. And of course that means the axis of symmetry is x equals h. And the dilation factor is a. Now let's have a closer look at how all these properties work together in GeoGebra, following this link here. Okay, you can see the parabola y equals x squared with some points marked in and some lines. More about these in a minute. However, at this point, notice on the left here, I've got a, h, and k. So I've got sliders, input boxes, but also you can see them represented in the equation at the top. Y equals a times x minus h squared plus k. Now, because a is 1, h is 0, and k is 0, we have x minus 0, so that's still x, right? And all of that squared makes x squared, and times 1 means we've still got x squared plus 0, well, we've still got x squared. So that's why this equation you can see underneath it, which is the actual equation for the parabola, and you'll see that change as I change these values, is y equals x squared. Now I'm going to write down these little facts when we get back into OneNote later. Now we have a turning point of 0, 0, and that's because h and k are both 0. And this graph is 1 higher than the turning point when I move by 1 to the right, or to the left. Also notice that both points on either side of the axis of symmetry are the same height and the same distance from the axis of symmetry, and this is why it has its name. Also note that I have the equation for the axis of symmetry up here. Now if I change this value of d to 2, then you can see we're looking at an x value of 2 more than the x value of the axis of symmetry. So that means that the height difference is now 4, which makes sense because 2 squared is 4. Notice how the point minus 2, 4 is a distance of 2 from the axis of symmetry as well, as being 4 higher. Now if I change the value of a to 2, this parabola is narrower than the original parabola, and the height of the points that are 2 away from the symmetry are 8. And that's because 2 times 4 is equal to 8. So if I make d 1 again, we can see that the height is 2, i.e. 2 times 1 squared. You should be able to notice by now that the length of this yellow line will be the positive value of a. So for example, if a is 2, it's 2 when the distance here is 1. And if a was minus 2, for example, it'll be still 2. So let's test that by changing this d to a half. So we can see now that a half squared is a quarter times 2 is a half. And now let's return a and d to 1 and make h1 as well. So if we look at the equation, we can see that it says y equals x minus 1 squared. So this means that subtracting by 1 moves a parabola in the positive direction. And this may seem counterintuitive first, but if you think about it, 1 minus 1 is 0. So when x is 1 in this parabola, it's behaving like x equals 0 in the original parabola. Now let's make k equal to -2. And if I zoom out a bit, you'll see the turning point here is 1, -2. So we've got an x value of 1 and a y value of -2. And this is because -1 inside those brackets moves the parabola in the positive x direction, and -2 for k moves the parabola -2 in the y direction. So we move in the opposite direction of what's inside the brackets, or we move in the same direction of k, or the number that's in the outside of the brackets. Now let's make a equal to 2 and see how the turning point doesn't change, but the height of this yellow line is now 2 and the intercepts have changed. Let's change h to -2 and k to 1. So zooming out here, you can see that we don't have any more x-intercepts, but we still have a y-intercept. Also notice the equation. So while h is equal to -2, therefore our axis of symmetry is x equals -2. Inside the brackets, we've got x plus 2, because that's -2. So if I change d to 2, the value of the y value makes sense that it's 8 higher than the turning point, because a times d squared is 2 times 2 squared, which is 2 times 4, which is 8. Now let's make one more point about making it a half. So no surprises, we'll see this line is now half of 2 squared, i.e. it's 2. Not 2, I mean it is 2 times a half squared, which is a quarter, so it's a half. Finally, one more point about this. If you sub in the value 0 for x into this equation, then you're going to find the y-intercept. So here h is -1 and k is 1 and a is a half. So when x is 0, we have 1 squared inside the brackets, times a half is a half, plus 1 makes 1.5. And sure enough, the y-intercept is at 1.5. And if I make a equal to 1, you can see that 1 squared plus 1 equals 2, and our y-intercept is 2. Also, I've not shown a negative yet, so let's make a -1 and see that the parabola is reflected about the x-axis. And the y-intercept has changed. Notice that the turning point is a maximum now, not a minimum anymore. But it's still the same point, and the axis of symmetry hasn't changed. And the yellow line is the same length. So let me zoom in to make that a bit clearer. So you can see the length 1 here. And if I flip between +1 and -1, minimum with a length of 1, maximum and a length of 1. All right, that's about all you need to know at this stage. So let's head back to OneNote and write down these rules and work through the examples. But before we go, realize that you're going to have to sketch parabolas based on equations. So use the equations to find the turning point and the axis of symmetry, and then find the y-intercept or another point if the turning point is the y-intercept. You also have to use these properties from a graph to try and figure out the equation. All right, now that we're back in OneNote, let me point out that you should be able to see that a parabola implies one equation and an equation implies one parabola. If unclear, use that GeoGebra app. And you're welcome to use that at any stage to assist your learning. The link is here in the OneNote. So let's make some notes about the links between the properties of the parabola and the equation. The turning point and the axis of symmetry have a clear relationship with the equation. And we've written it down above, but the h and the k give us the turning point, the x and the y values, and the h gives us the axis of symmetry. Now, the y-intercept is where x equals 0. So for the equation y equals a times x minus h squared plus k, the y-int is just subbing in 0 for x. And therefore we end up with a times h squared plus k. And the x-intercepts are for a later lesson, but involve solving a quadratic. So now we just need to find a from a graph. So here's a parabola with a turning point, hk, and here's some other point, which we'll just call x1, y1. All right, we don't know what that is yet. So it's going to have some distance, which we'll call d, in the x direction from the turning point to this point, x1, y1. And then there'll be some height difference as well, which we'll call e. So that means x1, y1 is equal to the point that has an x value of h plus d and a y value of k plus e. And the same is true for a parabola that's reflected in the axes. The only difference is that it's going to be h plus d and k minus e. So this height e is actually going to equal a times the distance d squared. So if I rearrange that, that means that e divided by d squared is going to equal a. So this is how we figure out what a is. Okay, we sub in these values e and d, and a falls out. And I should just notice for the other one, it's going to be minus e over d squared equals a. So formally, the way that you're going to figure out a is to remember that d is equal to x2 minus h, and e is equal to y2 minus k. And let me change the color of d there. So subbing in these values with the actual point, that means that a is going to equal y2 minus k divided by x2 minus h squared, provided that you've got the turning point and the other point. And so just to note that down, the turning point is h and k, and the other point is x2, y2. Okay, so h and x2 are just x values, and k and y2 are just y values. And it's worth noting that if h is not equal to 0, that the other point is usually the y-intercept. But if h is 0, you're relying on the graph having another point marked. All right, I know one day you're going to look back at this stuff and think super easy, but these sorts of things never are when you first see them. So I think for this lesson, it's really important that you pause the video now and work on the building understanding questions in the new book, which translates to questions 1, 2, and 3 in the old book. And then I'll see you in the next section. For the equation y equals a times x minus h all squared plus k, the turning point is always going to be a point with an x value of h and a y value of k. Now, because we need a second point to draw the parabola, if the axis of symmetry is x equals 0, i.e. y is equal to a times x squared plus k, then make your second point one with an x value of 1. And I've used this letter p for the y value. But in this point here, p is going to equal a times 1 minus 0 all squared plus k. And 1 minus 0 is 1, and that squared is still 1, so p has to equal a plus k. All right, and of course that's where x is equal to 1. So if the axis of symmetry is not where x equals 0, then just make the second point the y-intercept. Of course, that means x is equal to 0, so y is going to equal a times 0 minus h squared, i.e. h squared plus k. All right, so hopefully that's pretty straightforward. I know it's just algebra at this stage, and for some of you, you might need to see the numbers to make sense. So let's get on to that and apply these skills in example 3, where we're going to sketch the following graphs, labeling the turning point, the y-intercept, or where x equals 1. All right, so part A, we've got y equals 3x squared. Now we can rewrite that as y equals 3 times x minus 0 squared plus 0. And this hasn't changed anything, right? Adding zeros doesn't change a thing, but it is helpful to do this because we can see where the turning point is. So these here are our h and k. So this means the turning point is at 0, 0. And with an axis of symmetry of x equals 0, because that's the x value in the turning point, that means that we're going to find our second point where x equals 1. So subbing in 1 for x, we get y is equal to 3 times 1 squared, which is 3. So i.e. our second point is 1, 3. Let's draw some axes for our parabola. So our turning point is 0, 0, and our second point is 1, 3. And I can now draw in the parabola. So that there is y is equal to 3x squared. Also notice how after making the 2 points, I just use symmetry. All right, let's move on to part B, where we've got y is equal to minus x squared plus 4. So once again, that means y is equal to minus x minus 0 squared plus 4. Okay, because x minus 0 is the same as x. And just as the last time, that means that our turning point is using these values here, and we can write the turning point as 0, 4. Also note that there's a negative sign there, so that means it's reflected in the x-axis. And because h is equal to 0, that means our axis of symmetry is x equals 0. And so for the second point, we're going to go where x equals 1. And subbing that in, we get minus 1 squared plus 4, which is equal to 3. So then our second point is 1, 3. Let's draw some axes for these 2 points. So we know we've got a turning point at 0, 4. And our second point is at 1, 3. So we can now draw one side of the parabola. And by symmetry, the other side is the same. If I could draw properly. All right, let's move on to part C, where we've got y is equal to x minus 2 squared. So continuing on with this expanding idea, that means y is equal to x minus 2 squared plus 0. And therefore we've got a turning point of 2, 0. All right, those 2 points make it clear. And because h is not equal to 0, our second point is the y-intercept. And of course that's where x equals 0, so we've got y equals 0 minus 2 squared, which is just 4. All right, let's draw some axes for this parabola. So we've got our turning point at 2, 0, and our second point is going to be the y-intercept 4. So we can draw one side of the parabola, and by symmetry the other side is like so. Well, that's still terrible, isn't it? All right, so let's get on and pause that video now so you can do questions 1 and 2 if you have the new book, or questions 4 and 5 if you have the old book. So I hope you're not getting confused with me adding zeros and things like that. That's just to paint the picture of where the turning point is. So once you got the turning point and a second point, you have half the parabola and the rest is done by symmetry. If you want to be super accurate, you can see things like this parabola is badly drawn, because it should also have y is equal to 1 where x is equal to 1. Okay, you can sub that into the equation and see yourself. Anyhow, I'll see you in the next section. So this section is not too different from the previous one. The difference is we had all of our turning points on axes in the last section. So let's restate the rules. For our quadratic rule, y equals a times x minus h squared plus k. The turning point is h and k. Okay, don't get confused with which is positive and which is negative there, all right? And the y-intercept is just where x equals 0. So that's y equals a times 0 minus h squared plus k. And expanding that, we end up with a times h squared plus k. All right, so let's just move straight into example 4. Where of course we're going to be graphing based on some quadratic rule. All right, so part A will be y equals x minus 3 squared minus 2. So I shouldn't have to highlight it now. You can see that the turning point is 3 and minus 2. And the y-intercept is where x equals 0. So that is 0 minus 3 all squared minus 2, which is equal to 9 minus 2, which is 7. Okay, let's draw the axes for this parabola. So I'm going to mark in the points for the turning point. We have an x value of 3 and a y value of 2, well, minus 2. So here is that point, and our y-intercept was 7. So I can draw one half of the parabola now, and by symmetry we can do the other half. And that's really badly drawn. I'm going to do that again. All right, it still looks really pointy, but anyhow, that's the parabola. If we mark in those points, we're sort of correct, right? Oh, big mistake. The x value there is 3 and the y value is minus 2. Okay, so that's our turning point. And from there and one other point, which was the y-intercept, we've drawn the whole parabola. All right, let's move on to part B, where we have y equals minus x plus 1 squared plus 4. So I'm going to sort of expand this one again just to make a point that what the plus sign means inside those brackets. So you could rewrite that as y equals minus x minus 1 all squared plus 4. Okay, so that way we know that our turning point is minus 1 and 4. And we know that our y-intercept is where x will equal 0. So y will equal minus 0 plus 1 squared plus 4, which equals 5. Sorry, that equals 3. I'm not sure what I was thinking there, but anyhow, let's draw those axes. So let's mark in that turning point. Okay, so we've got a x value of -1 and a y value of 4. And I know that our y-intercept is going to be 3. All right, so let's start with our parabola and do the other side. All right, so there we have it. I've marked in the turning point, and a second point was the y-intercept. I drew half the parabola and did the other half with symmetry. So what you see here is a representation of y equals minus x plus 1 squared plus 4. All right, I don't think that'll be too tricky for you guys. Might be a bit of fiddling around at first, but as long as you find those points, the only other difficulty you're going to find is how hard it is to draw a parabola correctly. Anyhow, pause that video now and do question 4 in the new book and question 6 in the old book. And then I'll see you in the next section. All right, up until this point, we've been taking equations to draw graphs. So now we're going to learn to take a graph and find its equation based on a couple of key features. So if we have a parabola that has a turning point hk, then we know the equation will be y equals a times x minus h squared plus k. And we can find that h and k in the turning point. And if there's a second point on the parabola, which we'll call x1, y1, now this distance d is a change between the 2 points. And this distance e is the change in y between the 2 points. And this distance d is just equal to x1 minus h, and the distance e is equal to y1 minus k. So I know that I can find a as a times x1 minus h squared equals y1 minus k squared. Because all I have to do is rearrange that, and we're left with a is equal to y1 minus k divided by x1 minus h squared. Now in this lesson, the vast majority of a's that you will find will be 1. So let's just write down a shortcut to find a. For the distance d equal to x1 minus h1, minus h, or e equal to y1 minus k, if d is equal to 1, you'd expect e equal to 1. And if d was equal to 2, you'd expect e to be equal to 4. And so if you do find this, just stop, because that means a equals 1. But if that's not the case, then a is not equal to 1, and you're going to have to do the whole a equals e divided by d squared. Okay, so let's try this out in example 5. We're going to find the rule for this parabola. Okay, so because the y-intercept is also the turning point, we have a turning point of 0, 1. Therefore, h is 0 and k is 1. And subbing that into the formula, so far we've got y is equal to a times x minus 0 plus 1, which is equal to y equals a times x squared plus 1. So we've also got this other point 1, 2 on the parabola. So d is equal to x1 minus h, which is 1 minus 0, which is 1. And e is equal to y1 minus k, which is 2 minus 1, which is also 1. Because d is 1 and e is 1, which is what we'd expect, we know that a is 1. And if you wanted to check, you could say e divided by d squared is 1 divided by 1 squared is 1 divided by 1, which is 1. But let's not bother with that, okay? So because our a is 1, we know that our rule is y is equal to x squared plus 1. All right, so there's going to be a number of these to try in your pre-learning. So pause the video now and do question 6 in the new and question 8 in the old book. And then come back so we can summarize this lesson. So far, we've been exploring parabolas and the relationship with a quadratic equation. And seeing we're always working with a turning point, hopefully you've noticed how much that turning point form is like completing the square. We've discovered a lot of different properties of the parabola, but in the next lesson, we're going to start finding ways to find the x-intercepts. Okay, so for today though, a successful student will know the types of transformations, dilation, reflection, and translation, understand the effect of these transformations on the graph y equals x squared, know how to determine the turning point of a quadratic rule from the turning point form, be able to sketch a quadratic from a turning point form. And finally, be able to find the rule of a quadratic graph given the turning point and one other point. Alright, so that's it for today. Work hard, we'll see you in the next lesson, whether that's in video or in class. Bye.